Simplifying a rational expression with monomial numerator and denominator was relatively easy because monomials come automatically factored. We can just look at them and see what the factors are. When we have polynomials with more than one term, we need to factor first. So in this example, we have the rational expression 2x cubed minus 7x squared plus 6x over 2x cubed minus 16. And we want to simplify this. To do that, first we need to fully factor the numerator and denominator. So we're going to look at our numerator and denominator separately, and we're going to fully factor them. We have 2x cubed minus 7x squared plus 6. First, we go for the greatest common factor. It looks like these have a common factor of x. Pulling that out, 2x cubed divided by x is going to be 2x squared. 7x squared divided by x is going to be 7x. 6x divided by x is going to just be 6. So now we have a monomial, x, times a quadratic trinomial. Trying to factor this quadratic trinomial further, I think we need to use the AC method. I'm going to just work that off to the side a little bit. We have AC is 12, B is 7, negative 7. And looking at that a little bit, we see negative 4 times negative 3 is 12. Negative 4 plus negative 3 is negative 7. So we're going to split up that middle term as negative 4x minus 3x. Then we've got 2x squared and 6. As we go on and continue to practice with the AC method, we may skip writing out what AC and B are and just go directly to filling in our square. So let's see. First row, it looks like the only common factor is an x. What times x gives me 2x squared? Well, that's 2x. What times x gives me negative 3x? That's negative 3. What times 2x gives me negative 4x? Well, that's negative 2. Negative 2 times negative 3 equals 6. Yes. So my first polynomial factors, as we keep the monomial factor x, and then our trinomial factors as x minus 2 times 2x minus 3. What about 2x cubed minus 16? Well, first we have a common factor of 2. 2x cubed divided by 2 is just x cubed. 16 divided by 2 is just 8. Okay, our remaining polynomial has 2 terms. We want to see if this is a special form. X cubed is clearly a cube. Is 8 a cube? Oh, it is. It's 2 cubed. This is 2 times x cubed minus 2 cubed. So we'll have 2 times. First factor is x minus 2. And then the second factor is our first term squared, so x squared, plus the terms multiplied together, x times 2 is 2x, plus our second term squared, so 2 squared is 4. And the quadratics that we get out of a sum and difference of cubes, we can check using the AC method, but they're always prime. So that is each of our polynomials, our numerator and denominator, factored as much as possible. Now we rewrite our original rational expression with our numerator and denominator in factored form. So our numerator factored as x times x minus 2 times 2x minus 3. Our denominator factored as 2 times x minus 2 times x squared plus 2x plus 4. And now we look at this and we say, oh, x minus 2 is a common factor. And it looks like that's it. We have no remaining common factors, so fully simplified, we have x times 2x minus 3 over 2 times x squared plus 2x plus 4. Now, depending on what we want to do next, we may leave this, or we might multiply out. So x times 2x minus 3, that'll be 2x squared minus 3x. 2 times x squared plus 2x plus 4. Well, 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 4 is 8. And this one was pretty easy to multiply out, so I would probably do that. Depending on what we wanted to do next, the factored form might be easier. Let's just see another example of this process. Here we want to simplify the rational expression 2x cubed plus 3x squared minus 18x minus 27 over 4x cubed minus 12x squared minus 9x plus 27. Now, notice that 27 appears in a term in both the numerator and the denominator. You might be thinking, I bet I can do something with that. You can't. You cannot cancel shared terms because addition and division aren't inverse operations the way that multiplication and division are. You can't cancel shared terms. Those 27s might be a hint that we're going to see some common factors, but for now, we can't touch them. Instead, we need to take our numerator, 2x cubed plus 3x squared minus 18x minus 27, and our denominator, 4x to the third minus 12x squared minus 9x plus 27, and we need to factor them. Now each of these has 1, 2, 3, 4 terms. So we're going to try to factor each of them by grouping. Our first one here, filling in the terms 2x to the third, 3x squared, negative 18x, negative 27. Our first row, our greatest common factor is x squared. What times x squared gives me 2x cubed? Well, that'll be 2x. What times x squared gives me 3x squared? That'll be 3. What times 2x gives me negative 18? That'll be negative 9. Negative 9 times positive 3 gives me negative 27. Yes, just as I hoped. So this factors as 2x plus 3 times x squared minus 9. Now remember, we need to factor fully. So 2x plus 3, that's linear. I can't factor that any further. X squared minus 9, that's a difference of squares. Right, so I've got my 2x plus 3 times x squared minus 3 squared. So I've got my 2x plus 3 I just copy. And then I'll have an x minus 3 and an x plus 3. So my numerator, when factored fully, gives me 2x plus 3 times x minus 3 times x plus 3. Next, we're going to do the same thing with our denominator. We're going to factor it fully. So again, 4 terms, we start out by grouping. We've got our 4x to the third minus 12x squared minus 9x plus 27. Okay, so looking at our first row, it looks like our greatest common factor is going to be a 4x squared. 4x squared times what gives me 4x to the third? Well, that's just an x. 4x squared times what gives me negative 12x squared? That's a negative 3. X times what gives me negative 9x? That's a negative 9. Negative 9 times negative 3, is that positive 27? Yes. So to begin with, my denominator factors as x minus 3 times 4x squared minus 9. But remember, we need to factor fully. X minus 3, that's linear, that's prime. X squared minus 9, it looks like that might be a difference of squares. And in fact, it is. Right, 4x squared, that's 2x all squared. 9 is 3 squared. And so I've got my x minus 3, and then 2x all squared minus 3 squared factors as 2x minus 3 times 2x plus 3. Okay, now I've factored my numerator and denominator. I can put them back together. My numerator, I have 2x plus 3 times x minus 3 times x plus 3. And then in my denominator, I have x minus 3 times 2x minus 3 times 2x plus 3. And looking through for common factors, 2x plus 3 appears in the denominator. X minus 3 appears in the denominator. No x plus 3 in the denominator. No 2x minus 3 in the numerator. My rational expression simplifies to x plus 3 over 2x minus 3. The only way to find that out was by looking at the factors.